Everybody, this is 4.04. Right.
Wait, are you
So,
recording or you
yeah, I'm recording. Yeah, because I record for the other. All right, so 4.04. So, all right, so it says, what do you think of when you view the images? All right, so Yusuf, so what do you think of? You see these images here? All right, so what do you think of?
I mean, it's kind of normal over there. I don't
Right.
some dead fish.
Oh, it's normal. Okay. All right.
Yeah.
Well, I guess what you're supposed to think is that this is bad. A lot of pollution going on, right? So you have some deforestation going on, a lot of greenhouse gases going from the factories, things like that, right? So the idea is that they're saying that industry, all these things, they improved the well-being of people. More people can eat, stuff like that. So they're good things, and then also there's bad things. There could be pollution, greenhouse gases, contamination of the air, water, land. So those kinds of things. So industrialization, what is the harm versus what is the good, right? So that's just what we're going to talk about today. So we have the greenhouse effect, right? So you have like more like local pollution and stuff like that of the air, the air and the water, and then you also have like more global effects, right? So what is the greenhouse effect? Like, what have you heard about the greenhouse effect?
Traps greenhouse gases inside
Mhm.
the earth because the ozone layer, atmosphere, whatever, doesn't let it escape
Mhm.
or something like that.
All right, so there's something called greenhouse gases, right? So here's the idea, right? So you have these different greenhouse gases: water vapor, carbon dioxide, methane, nitrous oxide, and ozone, right? There's different kinds of gases, and what they do. So here's what they do, right? So normally you see on this page, right, the sun, right, it sends its light energy to the earth, right? Now when it sends it, then some of it is absorbed, right? Some of it is absorbed, some of it stays here, and some of it starts going out into space. So
Someone bounced over that. I'm confused. Is anyone in the class right
he's nice.
now? Why don't you just look at him, bro?
Okay.
It's awkward.
No, it's on the screen. I'm pointing to the screen. All right. So we have do you see the arrows? So once the light hits the ground, right? Some of it is absorbed, right? Some of it is absorbed and stays here on the earth. But then right? But also it starts to bounce back and it starts to head off into space, right? But what happens is that when you have greenhouse gases, okay, and also the light changes a little bit. It changes into infrared light. So when that starts to go out, right, the greenhouse gas, what it does is that it can't just go straight out. It gets captured along the way by these certain gases, right? So these gases, when they absorb it, right, they absorb that energy, and then they release it again. But when they release it again, some of it goes back down into the earth, right? So this energy, which was going to go which was going to go straight out back into space, right? Now some more of it, some extra is like retained. Some of the energy is retained in the atmosphere, right? So that heats up the atmosphere a little bit more than it should, or or than it would otherwise, right? So the idea is if you have like a lot more of these gases, right? So the thing is so these gases, they're also beneficial, right? Because otherwise, right, we don't want to be like just like the moon, right? Just like hot on one side and then cold on the other side, right? So you need to retain heat and warmth, because otherwise the whole earth would just be ice, right? Otherwise, so it's beneficial, but you want to keep it in like some kind of balance. So if you have too much of it, right? So some greenhouse gases are very good, but when you have too much of it, it could become, it could heat up the earth too much. So there's a planet where there's something called a runaway greenhouse effect. Do you know like which planet that is? That they say that there's kind of like an too much of greenhouse gases, too much of the greenhouse effect. Have you heard of it? So it's Venus. So they say that Earth and Venus, they're like very so Earth and Venus are about the same size, like very similar, but on Venus there's like too much greenhouse gases, and so they have like a runaway greenhouse effect. So the thing is, so Mercury, right? Mercury is actually closer to the sun than Venus, right? But Venus is actually hotter than Mercury because of this effect. So that's because it has all the greenhouse gases. So I think Mercury, I don't know how much gases Mercury has. Maybe it doesn't have anything. But the idea is that on Venus, because this effect is hotter than Mercury, which is the opposite of what you would expect based on the distance from the sun. Does that make sense? Right. So these are the different kinds of greenhouse gases. So water vapor. Right? So water vapor is everywhere, right? Water vapor is just from, is natural, right? Is from, what do you call it? It's just from the ocean. So when you burn something, right, there is some water vapor also produced. So some of that comes from burning things as well, but most of it is just from the normal part of the water cycle, right? Right, water evaporates from the ocean, goes up, form rain clouds, comes back, the water cycle. So that's where the water vapor comes from. Carbon dioxide, right, is also can be a natural part, right? Has always existed, or not always, but like has existed for a long time, because people are breathing it out, right? You're breathing it out, and they say even before that, the carbon dioxide was like a natural part of the atmosphere. But in addition, right, when you burn things, right, then you produce carbon dioxide as well. So when you burn, fossil fuels, right, coal, natural gas, oil, when you burn those things, a lot of carbon dioxide is produced, right? So methane is produced from many different sources. So they're saying that methane is more damaging.
Methane is from animals too, right?
Yeah, some animals. So methane is actually a more potent. Is more potent of a greenhouse gas than water vapor or carbon dioxide. So it's much smaller in amount, but actually, if you for every amount of methane, that actually traps more heat than the other two, right? But it's like a smaller amount. Now another thing is, so it comes from animals. It also comes from there's something called peat. Have you ever heard of the word peat?
No.
So people use have you heard like peat moss and stuff like that?
Yeah.
I think it's kind of like similar, right? So that's like in certain places where like when some plants, organic matter decomposes, but I think it decomposes in a different way, maybe like without oxygen or something like that. Then it forms peat. So for example, like I think in the Everglades also there's peat. So because like the Everglades is filled with water, right?
Yeah.
So it's like a swamp. So when the plant dies, it goes down into the water. It's not just like exposed to the air where it decomposes like stuff here. So down there, when it decomposes underneath the water, it forms peat. So when you burn it, that produces methane. Or when you burn it, or
You can burn peat.
I think decomposition. No, I think it's just produced by the decomposition. So like that process, somewhere in the process of making of peat, methane is produced, and so methane is more potent than water vapor, carbon dioxide. That's why they say that like using peat moss and stuff is actually not good for the environment. That's the idea. Even though it's like they say it's like very good for gardening and stuff like that.
Yeah, very good.
Nitrous oxide is another one. So this is also from fossil fuel combustion. So I think there's like nitrous oxide, and then also like certain like sulfur compounds. They come from so when you have coal, right? When you have coal, there's other kinds of things in there as well. There's sulfur compounds and different things in there. So when you burn coal, the main thing is carbon dioxide that they're producing. But some of these other kinds of things are also made there as well. Ozone is like O3, right? So oxygen, the regular oxygen that you breathe, is like 2 oxygen atoms together. O2. Ozone is O3. So in the upper atmosphere, ozone actually has a beneficial effect. Like what is like the beneficial effect of the ozone layer?
I think it retains the heat. It protects from extra ultraviolet, like too much ultraviolet rays.
Right. So from UV light, right?
Yeah.
So otherwise, people get higher levels of skin cancer and that kind of thing. So, but also apparently it is a greenhouse gas in too high of a quantity. In too high amounts. Right. So this picture is kind of showing the same kind of thing, right? So when solar radiation comes to the Earth, some of it that's supposed to be just reflected off instead is absorbed by the greenhouse gases, and then some of that can go out, but then some of that stays. So a little bit extra stays in the Earth, right? So that's the idea there. And these are just like some examples of different greenhouse gases. So we talked about some of these. and they're also mentioning sulfur dioxide, carbon monoxide, chlorofluorocarbons, different things like that. Right. This is kind of telling us like where a lot of these come from, right? So they're showing that from electricity production, obviously, right? Because that's like burning fossil fuels.
Yeah, but
Mhm.
I think it's mostly from what's it called? Agriculture. Sorry, like
So they're saying animals. So here they're saying 10% from agriculture. So I don't know. So I guess I don't know what the source of the numbers is, but that's what they're saying, about 10% agriculture.
It said that everything, all the planes, everything combined. I guess transportation, all the transportation and all that combined.
Yeah.
Agriculture, like the animal factories and stuff, whatever,
Mm-hmm.
produce more because they produce a lot of methane because animals fart and stuff.
Right.
Or whatever.
So it could be so I think in this case, like, this could be just the amounts of the gases, right? Another thing that you could look at is, okay, well, there might be different, what is the effect, right? So if maybe agriculture is producing more methane, in terms of its effect on the greenhouse effect, it could be a higher effect, right? But the amount is still 10%. So maybe it could be that so this could be the amounts of greenhouse gases, but if we look at what are the effects, right? Somehow if we were to measure like the temperature change because of each thing, it could be higher if it's producing more methane than other things.
Yeah.
That makes sense. Okay. All right. So there's different ways that the scientists determine and monitor the health of the environment. So one thing is called glacier recession, right? So what does that mean? What's going on in the picture there on the left? Yeah, glaciers are. So recession means like something going down or going away, right?
Yeah.
So this right over here on the left is presumably, earlier on, and then later on there's like some glaciers melting. So throughout Earth's history, right, there are different cycles of where glaciers are going up and down, up and down. There's regularly like an ice age and then a warming period.
Yeah.
So most of Earth's history is actually an ice age. So and then you have a short warming period and then an ice age, and the short warming ice age. But they're saying that so we are in a warming period, but they're saying that we're warming too fast compared to historically how we were supposed to warm. That's the idea that they're saying. So we have glacier recessions here. You have polar ice levels, which is kind of a similar thing. They look at how much ice there is around the North Pole. They look at animal migration and plant hardiness zones. So here on the bottom right, this basically tells you like different zones for different plants. So whenever you plant something, right, like on the back of the seed packet, they often have to number, like a zone number. And based on that, it tells you like what is the best place to plant this crop. Yeah, so you would say it might have like, this plant is really good for zone 6 and 7, something like that. So if you live in like zone 6 and 7, right, that temperature is like the best temperature for this kind of plant, whatever.
That's affecting the thing because the temperatures and stuff are being changed.
Right. So let's suppose there's a lot of warming. Well, then these zones will change. Like where it is warmer, will start to go more north, right? The areas that are colder, right? You see the ones that are like purple, pink, like that.
Yeah.
Those ones will start to shift towards the green and yellow type, right? You see the yellow, green, red. They'll start to move up and cover more area.
Yeah.
Does that kind of make sense?
Yeah.
So like where the animals and plants live,
that's
going to change. So that could be a sign that the climate is changing in this area.
Like affect like whole ecosystem.
Right. So if they see like an animal that really only lives in warm weather, and they see it up north where it shouldn't be, they might know, this is, the climate is changing in this area, something like that. All right. So this is also just saying that from rainforests and different kinds of marine environments, we obtain like a lot of medications and that kind of thing. So there's a flower called the rosy periwinkle, where they get medications to fight leukemia, which is a type of cancer. So we obtain lots of benefit, and obviously fish for food, right? Fishing and that kind of thing. So from the environment. So they're saying that like it's like so we we're not in like an isolated system where we wouldn't need the environment to survive. So we're dependent on everything that's around us. Right. Now this one here, this is just giving you like an example of the earthquake and tsunami destruction in Japan. So they're talking about environmental destruction, but also could be natural environmental destruction as well. So obviously the earthquakes and tsunamis, right? They destroyed a large part of the of the wilderness and that kind of thing. So for example, here frequently there's like a lot of hurricanes, right? So the hurricanes, when they come through, they cause like a lot of damage to trees in the Everglades. They might change things. So I was reading that. So there's like a bird here called the snail kite. Have you heard of this bird or not yet?
Yeah, the kite bird, right?
Yeah. So it eats like apple snails, right? It eats
Yeah.
snails. So I think during one of the hurricanes, so they have a lot of their nests around Lake Okeechobee area. That's what they say. So when the hurricane came through, it destroyed like a lot of the nests. And so as a result, their numbers, went down, right? So there's both like man-made, destruction of the environment, and there could also be, like natural destruction of the environment. So this is also giving us some examples. So I guess you guys can read through it, but basically they're just kind of giving you the story about what happened. Okay. All right. So this is just giving like. Okay. So in this on this page, right? There's not a whole lot of like scientific information. It's just telling you the story about what happened. And so when earthquakes happen, right? It can also, for example, it can cause a lot of fires, right? It can cause a lot of fires, and that can destroy things, right? When there's a nuclear, power plant that can, and it melts down, right? That can threaten the safety of like the animals around it, right? There could be animals that get cancer. There could be animals that are polluted and die because of it. There could be explosions at some of these different reactors, like they're mentioning here, right? So they're just mentioning like all kinds of different kinds of destruction can occur in many different ways.
So what does snail kite birds have to do with?
I'll just give you an example of how, so that was nothing to do with man-made, right? That was a hurricane that came through. When a hurricane comes through, right, it can destroy a lot of things. And so the hurricane destroyed. I don't remember which one it was. If it was Irma or something else, it destroyed a lot of the nests of the snail kite, right?
But kite birds actually can cause wildfires, right?
Oh yeah.
Yeah, they can carry flames.
Oh, they carry like what do they do?
Yeah, like in their beach or something. It's like what's it called? Articles on this in like National Geographic and stuff. Where like the California wildfires, for example, they somehow like help to spread the fire. I didn't read completely into it, but there's a way that they do it.
Oh, that's pretty interesting.
Called a black kite bird.
Oh, okay. All right. So this is basically talking about the same thing. There's not like a whole lot here. So they're just talking about nuclear reactors and how people have to balance the advantages and disadvantages and that kind of thing. So one of the things is, so another thing is that when they in like industry and nuclear reactors, so they often use water to cool things down, right? So what they do is that so the water is not polluted, right? However, the water is at a higher temperature than when they started out, right? Because if you use water to cool something, well, now the water has risen in temperature because it's absorbed the heat, right?
Yeah.
So you take water in from somewhere, from a natural source, a river, a lake, wherever you take it in, right? You heat it up, and then you put it back into the lake or the river. So that also affects the environment, right? Even if there's no like pollutants in there, just the fact that you change the temperature of the water and are now putting it back into the lake, the temperature of the lake changes. And so what kind of effect could that cause? Like, why would that be a bad thing? We're just heating up the water a little bit. We're not adding any chemicals, but we're just heating it up and then putting it back in. So what effect could that have? Any ideas?
I don't know.
Any guesses? So when water is heated, it retains less dissolved gases, right? So there's
Oh yeah, we
Mhm.
talked about it last
Right.
time.
so there's like more. So if you have colder water, there's more oxygen in it. You have warmer water,
There's like less oxygen.
less oxygen, right?
Yeah.
So when they put it, when they heat the water and put it back in, there's less oxygen there, and so fish can die, plants can die, right? Different organisms that live in the water now they don't have as much oxygen anymore, right? So that could be, that could not be good for those for the environment of the lake or the river and that kind of thing, right? All right. So this one over here again, they're talking about destroyed ecosystems as a result of the earthquake. So they're saying to begin, the earthquake caused the liquefaction of paddy fields. So meaning kind of like turning it into kind of a liquid kind of thing. Damaging many freshwater canals and waterways. However, it is the tsunami waters contaminated with city debris, salt water, radioactive elements, and chemical pollutants that have caused the most damage to coastal habitats, right? So the tsunami, right, when there was a tsunami, right, it by itself, just the force of the water can destroy a lot of things, right? But also, in addition, there's the additional effect that the tsunami now it can carry all kinds of debris and chemicals and pollutants and carry it somewhere else and damage so you have damage both from the chemicals and things and from just the force of the initial water itself. All right. So in this case, they're talking about different rivers and areas where there's different kinds of pollutants and things that have been taken there. So in this place right here, I guess Kitakami River, right? They're saying that the tsunami, when it went there, it carried salt water, right, which it normally does, but also pesticides, fertilizers, detergents, petroleum products, and human waste from the cities into the surrounding farms. And so that can kill fish because of diseases, decrease in oxygen level, different kinds of things. So another thing they were saying is that, like, for example, I don't know if you remember if like Hurricane Katrina, like a long time ago in New Orleans. Have you heard of that? When New Orleans got flooded. So they see that the water was like filled with all kinds of toxins and chemicals and stuff like that, right? Like whatever kinds of chemicals that were there, and maybe could be people's garages, could be, from industry, wherever, right? Now all of a sudden, the cans are broken, gasoline is spilled, toxins are spilled, all kinds of problems occur, right? And so the water is just filled with toxins. Normally Normally the toxins were in bottles and cans and things, right? But now they broke or whatever. And now the water is filled with toxins, and who knows where that's going and what that's affecting. That makes sense? We're talking about another one over here called Abu Kuma Highlands, I guess. So they're saying that there's a lot of radioactive substances that are spread. And so, what that can do is that can, when it contaminates, an environment, it can cause cancer especially, right? But it can also cause cancer, right? Deformities, right? When there's the next generation is born, babies are born, they can have deformities, right? So different kinds of problems, occur, as a result. So this is something called secondary succession. So what happens is that when something burns down or something gets destroyed, right? So when something gets destroyed, right? Basically, the top layer is destroyed, right? The top layer. You see, there's no more plants, animals, whatever was the top layer above the soil, above the ground. Now that's gone, right? So it takes a while for things to restart, all right? But this can restart, pretty quickly. And the reason is because you see down below, you still have the base, you still have the soil, you still have the nutrients in the soil and stuff like that, right? So you're not starting from scratch. You're not just starting from like rocks, right? So primary succession. So I think that was in 4.03 actually. Primary succession is let's say you just have just rocks. That's it. There's no soil, nothing. You're just starting from like a new volcanic island, right? In the middle of the Pacific, right? Where inshallah we're gonna be going next year.
Inshallah.
All right. So
Right now.
Go jump in a volcano.
So when you have like a new volcanic rock, right? There's no soil, nothing there, right? So that you know, to turn that all that into soil in a place where like even like trees that need deep soil,
That's primary succession.
that's primary. That takes a long time.
Secondary succession is from the soil to the
Right.
climax community.
Right. So secondary succession is basically where like primary succession occurred a long time ago,
Oh.
but you know the top layer got destroyed, but the base, the soil, and everything is still there. So it's easier to restart. Right. So when these disasters occur, this is called secondary succession, right? Because things were growing there before, and so now the process is restarting. So it's quicker than primary succession. Right. So our impact on the environment. So this is talking about, you know, one thing is that, you know, when people have pets and that kind of thing, especially in this area, there's a lot of like invasive species, right? So they're talking about lionfish. So they're saying that in 1992, a lot of people released lionfish into the Biscayne Bay, right?
And there's like the infested reefs and stuff, right?
Right.
And they're like eating that, yeah.
So this is kind of showing like where all those lionfish are now.
Yeah, you can like fish for them for
Mhm.
like
Right.
money.
So what other kinds of like invasive creatures are there? There's like a
Is
famous one.
Yusuf in
Birds,
class?
Python, lionfish.
Yeah, Burmese python, like different kinds of snails, stuff like that. Right? So these are all like invasive species, right? So I guess people had pets of those snakes and they released them into the Everglades or something like that. So they say that it's probably here to stay now, right? Right. So human expansion, you know. So this is talking about, you know, just the fact that you know people need space to live, right? They need, you know, like they would say like living space, right? So.
Is Yusuf Bashir at school, brother?
Oh, what happened?
Is Yusuf Bashir at school?
Yeah. So Ali and Yusuf are here at
Hey, who's that? Who's that?
at school. Anas.
Brother, why don't anyone come here? I'm so bored.
So, so let's just go and finish quickly. I think it's like 2 more slides. So this is just saying that, look, you know, human beings take space, right? So for that, areas like rainforests are cleared and stuff like that. So there's also another thing called slash and burn. Have you heard of like slash and burn farming? Anyone heard of slash and burn farming?
Why do you know all these?
Wait, what? Slash? Yeah, I've heard of that.
Slash and burn, right? So oftentimes that's in the rainforest, right? So you slash, you cut down some trees. Right. So, you know, slash and burn farming is when, you know, so you slash something down, you cut down the trees, you farm, right? But in the rainforest, right, the soil is not very good, right? Or it's you know, most of the nutrients are not there, and so what they do is they use it for a little while, and then after that it's done. You can't, you know, you're not going to grow crops very well anymore, so you got to keep going. So you got to cut down the next patch, and then you know, grow somewhere else, right? Right. So the idea is that, so like historically, that could have worked, right? That people have been doing that for a long period of time, but it's just in the past the population was usually less, right?
Now it's like 8 billion people.
Yeah. So yeah. Because the
thing.
thing is, so before what happened was that when you do slash and burn farming, now the old land is just left there, and so now it can regrow, right? So, but now it's not that the old land is left to regrow. Now it's being used for something else. So the rainforest never comes back, right? So this is just saying that our choices affect the ecosystem in big and small ways, right? So in this case, so they're saying that, you know, when it comes to, you know, pesticides, that people are starting to use more like natural pesticides and that kind of thing.
That doesn't change anything.
So, yeah, so those things that are organic pesticides, they could still also have bad effects, right?
Exactly. Yeah.
One of the
They
thing-
just wanna feel good about themselves.
It could be, yeah. So one of the things is that, so especially amphibians, right? So amphibians and reptiles, they're killed by a lot of pesticides as well, and especially amphibians because their skin is very porous. It's very chemicals and go through very easily. That's why you often see like those frogs with like 10 legs and whatever, right? You see those kinds of things because amphibians, right? Water and substances just go right through the skin, back and forth, back and forth. That's why they always need to be in like a wet environment. They can't be like lizards and just come outside whenever they want. They only come out when it's like raining because that's when it's moist outside. So, but what happens is that as a result, right? If you have any kind of chemicals, they're easily affected by it because they don't have protection. They don't have like thick skin, like lizards and kind of reptiles, right? This is the same thing. There's just saying we produce a lot of garbage and stuff like that, right? So sustainable practices. So the idea of sustainability is just that whatever someone does is that it can be maintained for a long period of time. So for example, let's suppose the rainforest regrows at a rate of 5%, then you would only use 5% of it per year. Does that make sense? The idea is that, so if you know that, so whatever is the rate that the rainforest can regrow, you only use it at that rate, right? Because there's like competing, so like if you're using it faster than it's regrowing, then you're always going to be cutting it down, right? So the idea is that sustainability, whatever it is that we're doing, that we should do at the same rate at which it can be regenerated, right? So that would apply to anything. That could apply to farmland. That could apply to decomposition of pesticides and fertilizers. So for example, let's suppose a pesticide lasts, in the earth for a certain amount of time in the soil, right? Because it takes a while for it to decompose and go away, right? So we only use it at the same rate at which it can be decomposed, because otherwise it can start to build up in higher quantities. So if we use it at a slower rate, so that whatever amount we use this year, that same amount decomposes and goes away in the environment.
So that it doesn't affect too much.
Right. That way it doesn't build up. The levels doesn't build up. It just stays at a small concentration, safe concentration. So that's kind of the idea behind sustainability.